you need something different. So yeah, thanks so much for having me. I work for NOAA Fisheries, and today I'm going to be talking about what happens after a whale dies, and primarily I'll be talking about what we call a necropsy. So that technically means a death investigation, and for some reason, a reason I don't know, when we do a death investigation on our own kind, we call it an autopsy, but when we do it on another animal, we call it a necropsy. And as noted and said everywhere, there's graphic content. There's a lot of graphic content and guts and things like that. And so I just want to encourage everybody, take care of yourself. If this isn't like what you want to see, look away or step out, and we can have some puppy breaks as needed. So Lizzie did a great job of introducing me. Thank you. I do a lot of different types of management work, and I lead our humpback whale program at the Alaska region. And occasionally this gets me in a place and position where I'm crawling into a whale. And you gotta ask yourself in those moments, like, how did I get here? What are the choices I've made, and how did I end up in this spot? And I don't know the answer to it, but what I think is might be relevant here is I was recently having a conversation with my family where we were sort of reminiscing about childhood, and my family described to me that I was the weird one. Yeah, and this is actually worse than that because I have 5 siblings, so like a huge family, and I was the weird one. And I was really surprised to hear this. My husband was really disappointed to hear that he married the weird one. And then they brought forward some examples. They brought some evidence forward, and it started to make more sense. But they described a time that I got in trouble for bringing dead birds into my bedroom. And I think that there were some early signals, some tendencies, and I think that I've always been really interested in the way that animals work and the way that they're put together. And I just want to congratulate myself for not going down the path of being a psychopath, but instead using it for good and helping marine mammals conservation. And it seems like, this seems to me like this might be of interest to other people too, because look how many people we got out tonight on a Thursday. Okay, so some of the nuts and bolts here. The Alaska region is responsible for the Marine Mammal Health and Stranding Network for Alaska. We have formal partnerships with groups all across the state who are authorized under official stranding agreements to operate on behalf of the stranding network and collect samples for us because it's a big state. We can't do them all. All of the work that we do, especially for endangered species, for all the humpback work we're doing, is under these 2 permits. So just that to say the carcasses themselves are protected, and all the photos that I'm showing you tonight are collected under those Marine Mammal and Health and Stranding Network permits. The primary objectives are to learn the cause of death. We're also interested in general baseline information, not only information about the species themselves, but we need to understand the frequency of these strandings. And then we're also looking at focus studies and collecting samples to support all of these other goals. We have a stranding hotline, 24-hour hotline. I'm going to show this again at the end of the presentation, but I would encourage everybody to put it in your phone because we get most of our information from the public reporting strandings. And oftentimes people will call us and say, I'm pretty sure you already know about this, but we have, such and such on a beach. But oftentimes we don't, and we really rely on the eyes on the water to help us get those reports in the first place. So for me personally, a necropsy is an opportunity to make the most of a tragic situation. It's the chance to learn the cause of death and try and learn from what happened to the animal so that we can best put our efforts into preventative mitigations. And it's also just the best way to make the most out of a sad situation and really try to let that animal contribute to science. Alaska is so vast, and something as large as a whale can actually be really hard to find in the first place and really hard to get back to. And when we have a report, we have a known location of a large animal, we've established that we're willing to put in the resources to go and do a necropsy. It can be really tough to get there. We typically are relying on a remote transportation, usually float planes, and we've got a reputation with Ward Air at this point. They know that we come back smelly no matter what. This is from a couple of years ago, and this was just happened to be a team of us that went out to an island near Angoon to do a necropsy, and this happened to be an all-female team, and I don't understand it. Nobody studied it, but for whatever reason, in Alaska at least, most of our teams are predominantly female. I don't know why. One of our largest constraints is to work around the tide. So we have to time our efforts around the tide cycle. We try to show up early, and that usually means a lot of waiting and a short working window. So we're waiting, and sometimes more patiently than others, for the tide to drop long enough for us to work. And then on the flip side of that, as the tide comes in, that usually is what makes us have to go home. And sometimes we'll even sort of be threatened to be marooned out on a whale as the tide comes in and people on shore are yelling to us. This is a Lynn Canal sperm whale, unusual species for us to have, but this was 2019. So a necropsy is a very big job, and it requires a lot of muscle and putting a lot of energy into a lot of teamwork. And I think sometimes it's hard to even sort of imagine, as you're peeling away sections of blubber and skin, that you're peeling away hundreds and hundreds of pounds, and we really have to work together and use leverage to try to reveal internal organs especially. So this is a time lapse of a whale that was on Douglas Island, and it's quick, but I'm just going to let it cycle a couple times so you can see it, because it's just kind of gives a sense of how many people and how much teamwork needs to happen there. And everybody who was part of this was absolutely exhausted at the end of the day.
What is the length of time in real time?
I don't know for sure. I'm going to guess maybe 4 hours. Yeah, that's okay. And in Alaska, we have our own set of challenges. We're the only region that has to regularly have somebody who's on bear patrol for our necropsies. So we always have somebody who has a shotgun, who can be keeping their eyes up, and especially on the forest, because as you can imagine, the smell of such a resource can really draw in scavengers. And regardless, we're almost always at mercy of the way in which the animal lands on the beach. And they're just so huge that there's no changing it. We can't scooch them around. You don't, have the opportunity even to move a pec fin or something. It's just the way that animal lands on that beach during that tide cycle is what you have to work with. And sometimes that will change what we have access to and what we don't. So let's talk about the gear. There's some gear. Typically, the stench of this is it's the blubber in particular. It's so penetrating, and the oils, the molecule oils are just they're a stench that just won't go away. So I tend to buy pseudo disposable gear and try to reuse it as much as I can. But if I need to, I can ditch it. And you know how like you go over your boots and things, like that's pretty inevitable. But then if you get this duct tape belt and duct tape around your arms, and you can try to prevent going over everything else. But you're really diving in. So for this talk, I'm planning to just walk through sort of some of the scenarios, some of the things that we will collect from an animal. So this is a theoretical unfortunate animal. We'll name him Jinx, and there is no animal with a Southeast ID 13, but if there were, it would be him. Here are some of the samples that we're going to be looking at, and I'll just walk through them one by one. So we'll have a chance to take a closer look at each one. So morphometrics, that means taking external measurements of the body. We do this every time, and sometimes the measurements are difficult because of the way the animal's laying or the tide being high, but we try to get those bits of information, which, as you can imagine, they're really challenging to get that from live animals. And then we're always looking for signs of external trauma. So it's something that we do right off the bat before any cutting occurs. Start to look for signs of what could have contributed to the death. So here, we have an animal where there's some pretty obvious external trauma, and there's even paint from a boat. So this is a vessel strike or ship strike. This is that sperm whale that was in Lynn Canal in 2019, the same animal. So the tail's over there, and the head that we saw in the other pictures over this direction. And even though it's fairly decomposed, you can still see these really large curved lacerations. So this animal experienced a prop strike from a very large prop. We're generally quite interested in trying to figure out who they are and the photo ID aspects of this. I'll just pass these around, but these are a flyer that I put together for whales in Juneau, but it gives you an idea of the variations of fluke patterns, and we use these fluke patterns to track whales through time. And so they have varying degrees of black-white scarring, and then the shape of their flukes and the trailing edge varies such that we can track them through time, and then when we have an animal on the beach, we can often figure out who it was and link that mortality to the life history sightings of the animal. And for those of us who are in marine mammal work, we use photo ID all the time. It's really the bread and butter of research. And I think it's really cool to mention that photo ID is a method that was actually pioneered here in Juneau by the Drows family and Sea Search Limited. And they started in about 1968 and recorded some of the first photographs to document individuals. And we have the ability to know some of these animals with really pretty long sighting histories. So we have several catalogs that show which animals are which. So I brought a copy of the Juneau Flukes catalog. This is a nonprofit that I run on the side, but I helped catalog whales in the Juneau area. And so we have the whales that are seen here. And then there's a database of whales that is curated through Glacier Bay National Park and Preserve and University of Alaska Southeast. It's actually very comprehensive for all of Southeast Alaska, so a much larger data set. And larger yet, we have a new data platform, which is called Happy Whale. And it's a citizen science type platform. It's also used by scientists. And you can gather data on the website, but also it uses automated matching through artificial intelligence algorithms to match flukes for you. So it's using basically facial recognition software, and you're able to track whales across the globe. And it's really incredible, and it's changed the way that we can learn about animals. And especially when we have an animal that's died, we really want to get that broader life history. So to get a photo ID image of a dead animal is actually, it's a lot harder than it sounds. It's a really odd angle, and it's difficult to get the same type of view that you would get from a live animal. Ideally, what we do is you would bring a ladder, so you could climb up a ladder and then position your camera over the flukes and take a picture directly down. But when we're flying in a float plane, that's not an option. And so what we'll often do is just take pictures and stitch them together later. But you really have to find a way to change that perspective so that you can orient the animal's flukes in a way that you can then match it. I've got a couple examples of some animals that died in our area. This one was on the right here, was being towed at the time, and a photograph was showing just a partial blade of the fluke, but we were able to match it to a long-sighted animal, first sighted by the Drazas in 1975. A female, her name was Max, and get really good information about her entire life that contributed to the necropsy. Also, another really well-known, really well-loved female that has a long sighting history, first seen in 1977. Her name, it was Spot. And amazingly, in this case, where we had an animal that had no more skin left on its flukes, the skin had deteriorated off, we're able to take images from the surface and get help from Sean Nielsen and Janet Nielsen to stitch them together, use Happy Whale, and find a match. So we knew, even this one, who it was. And it's just sometimes helpful to get that closer look. And when you're doing photo ID work, I spend a lot of time looking at flukes. And it's so interesting to see them up close and to see what those scars are that you're spending all your time matching. And so, as an example, these circular scars, they come from these specific type of acorn barnacle. I will pass a couple around if you promise that they'll come back. So, there's 3 of them. So these barnacles are acorn barnacles that are only found on whales and predominantly on humpback whales. And they are really fastened into the skin, and you can see sort of how those, once they fall off, how the scarring works and contributes to some of the markings that we might use to differentiate them. Okay, so next we'll go into skin and blubber. Take a little break here. How are we doing? It's also a reminder for me to take a sip of water and check my timing. I think we're doing pretty good here. So there's a lot that we can learn from skin and blubber, including all the things that are listed here. I'll just run through them. So steroid hormones, we can understand more about their stress response, their pregnancy status, and the maturity. Stable isotopes can tell us about their trophic level and their feeding habitat. Fatty acids about more like the prey quality, how good was the prey. We can look for contaminants, including PCBs and PFAS, which is synthetic flame retardants that are cropping up more and more. We can look at genetics, so we can see the genetic sex, we can see stock, species, and even individual. And then we can validate our biopsies. So this is, these are photos of biopsy samples that are taken from live animals using a crossbow. And I can mention more about this in a minute, but basically, while we take these blubber samples from live animals, we've used skin and blubber samples from necropsied animals to verify that what we think we're seeing is what we're seeing. We can also use blubber as an indicator of their health as a health metric. So we can look for how fat they are and take measurements of the blubber depth throughout the body. And we're interested in both eyes and ears, predominantly as aging methods. So the eyeball in mammals is a really great place to look at aspartic acid because the lens is not really actively metabolic. So it's pretty stable throughout the life of the animal. That lens doesn't really turn over through the course of its life. So you can start to look at this aspartic acid. It's called racemization. It's the way that the chemical compound manifests. But it changes, even though the lens itself doesn't change very much over the animal's life, but the acid does. So you can start to see how old an animal is by looking at the eyeball. So then we're also really interested in the ear. And I will pass this around. This is really, I think, great to hold. It's an ear bone from an adult humpback whale. And it's really heavy to capture sound. But in it is a ear plug, a waxy ear plug. And that is used to age whales, much like annuli on an otolith or rings on a tree. There's these annual growth layers that are put down. And so if you can get to this, you can get that earplug and age an animal. So I'll pass this one around here too. But the ears are really hard to get to because whales don't have external ears. They're buried within their head. In fact, the auditory bulla are sort of like in the near the throat. So if you're going diving for earplugs, you really got to get in there. So it can be challenging, but in this picture, I'm holding an earplug after a successful deep dive into that animal. And then this is what that I think it's actually the same earplug looks like, cleaned up. It actually looks to me like petrified wood. It doesn't look waxy, but it is. And then when it's prepared properly in labs, it can be aged. So getting into the guts is like is kind of next level with necropsies. We don't always have the time to do that in a necropsy, but that's where it's more labor intensive, but there's a lot to be learned. So in guts, we can learn about their prey, what they're eating. We can look for signs of harmful algal blooms, which are more and more of an issue with climate change and can impact marine mammals and other animals because they have neurotoxins that impact the animal and sometimes can lead to their death. You can look for parasite loads, can look for marine debris. I have not seen marine debris in the stomachs of whales, but there are examples where in other parts of the world where they've opened up stomachs and found large pieces of plastic and things that probably contributed to the animal's death. They can look at microplastics as well, which they're more of a looking in the tissues to see what's making its way through the food chain. If there's opportunity to look at the reproductive organs, then you can learn more about their status and history. In females, the uterus actually there's scars on the uterus that can indicate if the animal had successful pregnancies. So you can start to learn about her reproductive history. And then histologically, you can look at diseases, infections, how the organs are functioning, and you can look for an inflammatory response, which is really important because that both tells you things about the illness and health of the animal, but it can also tell you things about trauma. So, just some guts. And you know, I don't even know, sometimes you don't even know what you're like, you don't know where it's coming from, but sometimes there's lots of mysterious fluids, and they can be spraying, and it's can be really unpleasant. And what's always interesting to me about a whale is that you have as much tissue and sample as you could ever want, you know? So this is a piece of the colon from an animal that was eating krill, and you know, like that's plenty. We don't need more. We don't need more than that. In fact, the first time I went to necropsy, a different sample, but my advisor Beth Matthews said, "Could you please get me a skin sample?" And I said, "Yes, you bet." I came back to Juneau with a skin sample for her. I had taken like this. And she said, "I'll meet you at the dock." And she met me at the dock with a little vial. Yeah. Okay, so you can look for parasites. And we rely on our veterinarians to really help us interpret these types of things. And I just wanted to note that I find it really difficult to interpret internal parasites because we all have them, whales have them, and then whales are huge. And they naturally have these pockets of parasites. It's just terrible. But what is normal can be hard to compare. So we rely on our veterinarians. Okay, so baleen. I brought some baleen to pass around as well, and I'll pass a couple. Maybe just anything I'm passing around, if we could just have it end at the back table would be good. Yeah, they're sweet. Thank you. So we collect baleen when we can, and these are preserved in small sections on the rack, and it helps to show a little bit better how it functions. When I dried these, they curved, so they're not curved in the mouth. They're straight, but the prey gets trapped here on the sieve. So here, I'll pass that around, and we collect baleen when we can. Sometimes it's pretty easy. This is a photo of a rack of baleen that came off a calf, and it was pretty easy to remove. But other times it's really tough. And you know, it requires sawzalls and other things, and it can be really challenging to extract it. And this piece here is what is going around here. Yeah. So we've become really good at cleaning and sterilizing baleen. If you ever need to do it, we have really good methods. But from this, we can learn a lot. So it turns out that baleen is growing through the animal's life, and it lays down a history of the physiological environment that they are growing. So this is a picture of a piece of bowhead whale baleen, much longer, which records, for bowheads, it's about 40 years that it'll record. But you can see these lines have been etched in there, and those etchings can then be tested in the lab for hormones, stable isotopes, and other things to put back a history of what that animal experienced as it was growing. Humpback whale baleen, much shorter history is recorded because their baleen turns over faster and it's shorter, but still 3 or 4 years of what that physiological environment of the animal. So then we're looking for bones and tissue. I won't pass this around, but I've got a vertebrae if you're interested to see it. On the East Coast, when they do necropsies, they have, like cars and stuff that can go right up to the beach, and they take their time. Sometimes they'll do like 3-day necropsies, and they'll get down to the bone and look at all the bones. We never have time for that. So sometimes we have information about an animal that suggests cause of death. For example, a whale on the bow of a ship. However, it's important that we investigate the tissues, because we know that whale was on the bow of a ship, but we don't know if that's why it died. We don't know if it could have been floating and scooped up, and because it was floating, it was just an easy target. So it's hard to say, and we still have to look for evidence of that kind of blunt force trauma. So we can look at the tissues. Here's an example of a calf that was clearly experienced blunt force trauma. There's bruising. So you might recall some of the other photos. There's bright white baleen, and we've got a lot of bruising there. Same for this adult. So I really just have one more case study that I was going to bring up today, and it's another vessel strike accident. So we had a vessel struck whale this summer. It was the calf of a really well-known and well-loved whale in the Juneau area. So these flukes belong to a whale that we call Sasha. And Sasha, if you've been on the water, you've seen her. She hangs out at South Shelter, Portland Island area. She's really reliable in the Juneau area. She's really easy to recognize because she has these scars that really make her stand out even without showing flukes. She's got this big line scar here and a notch. But she's a great mama. She brings back babies. And this year, this 2023, she had a calf. And through the Juneau Flukes catalog, when naming whales, we sort of go with a naming convention of the mom's name, starting a theme from that. So Sasha being a dance style. This year's calf was named Tango. And Tango had a history with vessel strike. He actually had a couple of superficial vessel strikes, or at least apparently superficial, when he was alive. And so we had kind of been watching them and watching how they were healing. But we think that maybe even as many as 3 vessel strikes from small vessels prior to a vessel strike that was obviously from a larger vessel, a ship, and was fatal. So Tango washed ashore on Hump Island, which is north of Admiralty Island, and we were able to collect samples from Tango as well. And I think that this particular death of this calf was really hard on our community. A lot of people knew this animal and looked forward to seeing it, and I have to agree. I felt like it was a harder animal to walk up to, and I just wanted to end on, as scientists, we often come into these situations feeling like we must dissociate from any sort of emotions. We cannot bring in the emotions into our process, and we need to, follow this procedure and not, get wound up in those feelings. But more and more as I get older, I've realized that I just don't think we have to do that, and I'm sort of rejecting that as a construct, and I'm trying to find more space for myself and encourage it in teams to just take a moment to let yourself feel some compassion for the loss and grieve the loss that is. So, hopefully we can all sort of take that moment and sort of honor the animal in some way before we pull out knives. And then we're never the last ones there. there's always scavengers who are coming in to feast on this huge resource that was not there and then is all of a sudden there. And you'll see a total ecosystem shift. And eventually, the carcass will go to bones. And this is the only point in which it's legal for the general public to take home part of a whale. And naturally, it's complicated. It's really complicated. So you can't take home anything from an Endangered Species Act animal. But we sort of make this exception for humpback whales in Southeast Alaska because there's not as many listed. So you can, but there cannot be any soft tissue on the bones. They have to be dry. And you can register, they have to be registered. So you can register them with Bob Marvell, that's his phone number. And there's also an opportunity there to sort of like verify, like people will come to us and say, I got this bone, I don't really know what it is, can I keep it? So that's helpful, and if you have that opportunity, that is it's the beachcombing clause, and you'll finally have the opportunity to make that beautiful lamp you've been thinking about. So there's a dead whale here, and I just wanted to reiterate the hotline, and say, we wouldn't be able to collect the data that we have so far and make these really important discoveries about trends and emerging concerns without the reports that we get from the public. Our state is so huge. There are sometimes so few eyes out there, and it actually can be really difficult to find animals. They're a needle in a haystack. So thank you for those reports. Please continue to send them in. And this is my son when he was 4, poking his first whale with a stick. Just so proud. Yeah. I'll take any questions. Yeah.